And with that, I'm going to leave you with Joel. He's a customer engineer in the EMEA region, and he's going to present us today Apigee gRPC streaming deep dive with GCP Service Extensions. Thank you so much, everyone, and take it by Joel, please.
Yes, thank you, Alexandra. I'm going to present to share my screen. Sorry. Okay, perfect. I think it's okay. Maybe you need to set a recording, Alexandra, or I can start. Yeah.
Oh, it's already recording.
It's already okay. Sorry for this. Okay, perfect.
No problem.
Thank you.
Go ahead.
Yeah. So the topic of the day, as Alexandra said, is gRPC streaming with Apigee Service Extension. And there are two topics, that are important, on this title. The first one, as you can read, is gRPC streaming, and you will see that we have a possibility to handle this type of communication with Apigee, and we will do this, through what we call service extension. Yeah. So I just would like to, before going into the gRPC streaming topic, just do a quick sum up of what is service extension on Google Cloud. Yeah. So as you know, the application load balancer on Google Cloud use the Envoy technology. Envoy is an open source proxy that is very widely used on the market, and this is exactly the technology that we are using for the majority of our application load balancer at GCP. So just to explain what service extension is, a quick overview here with a very basic example. So we have a client here, an Envoy here proxy, and you can recognize here on this little panel, little diagram, the load balancer logo, which means, of course, again, that our application load balancer use this Envoy technology. So we have the client and the upstream, which is everything behind the load balancer that needs to be reached by a client application. Okay, so this is the Envoy technology, proxy between client and different providers, upstream backend services. What we can use with Envoy are what we call HTTP filters, and one of these filters is the external processing filter, also known as EXT-PROC, external processing. And this external processing filter is very convenient because this is something, a process, that we can call, that Envoy proxy can call before reaching the upstream. Okay, so as an example, my client here, and what is also important is that you can reach this external processor on the request or on the response, or the response, I should say. Okay, and it's very convenient. I'm just going to provide a quick example. I've got a client here that needs to connect with some upstream. It performs here an HTTP GET with a specific, of course, host names that correspond to the Envoy proxy here, some headers, and let's say that I need, to set some specific headers at the upstream, but this header, needs to be somehow calculated, determined by the Envoy proxy itself. Okay, so the request reaches the Envoy proxy. The Envoy proxy can delegate this set of headers to an external process, something that will implement a specific logic, specific business logic, to calculate, to determine the exact, headers that needs to be set, to come back on this example. And once this process will have been executed, the Envoy, proxy, the load balancer, can inject, if this is what needs to be done, can inject this header to the upstream in order for the upstream, to work with these specific headers. So this is the idea. The Envoy will not execute the business logic itself. It delegates, this logic to an external processor, and this external processor will manage the business logic or technical logic, and in order to, as in this example, inject some custom headers into the flow for the upstream. Okay, I could also operate at the response level, so a response back from the upstream can go back to the external processor. The external processor can again execute some specific type of processing, and we can send back the response to the client application. Okay, and so this is exactly what we have today. This is a feature or capability that has been included into application load balancer for a long period now, and this is a technology that we have at our disposal at the application load balancer level. So we have client application that needs to reach different type of backend applications through a load balancer, application load balancer, let's say a GCP L7 load balancer. We can use this type of service extension. We have other type of extension which consist in plugin that you can directly embed into the load balancer itself. Another type of extension is what we call a gRPC callout. So a piece of code, again, that we can execute outside of the load balancer, and that can process some specific type of logic. Okay. So this is the idea of service extension, to be completely clear. And in the case of APGX, the extension will consist in calling an API proxy that will be set at an APGX organization level, deployed on a specific environment. So we have a dedicated environment group that we create on the APGX platform. On this dedicated environment, we will deploy an API proxy, and this API proxy can be a call from the cloud application cloud load balancer through a service extension. So it's a gRPC call, to reach the service extension, and from there we are going to call this API proxy that will execute some specific type of processing. It's a targetless proxy. There is no target. When you create an API proxy on Apigee, you can set your API proxy as a no target proxy. This is the case for this type of proxy, and the idea of this proxy is to perform some specific type of processing in order, to give back the end to the load balancer that will reach the backend application. The backend application will execute some logic. The response will go through the load balancer, and on the response side, we can go back, if needed, to the API proxy in order to execute some specific type of processing that would need to be applied at the response level. When it is done, then the response can be sent back to the client application. So this opens, the door to some new type of use cases, like, for instance, something that is not supported directly on APGX, which is gRPC streaming. We support gRPC, what we call unary gRPC on APGX. So it's a client server type of gRPC mode, very close to what we can do with HTTP, of course. So clients send a request, the proxy performs some processing, goes to the gRPC service, the response is sent back, and processing again at the Apigee level, and we send the response back to the application, to the client application. That's unary gRPC. But when we need streaming, these type of use cases are not supported on APGX. And I will show you an example where we have a streaming, an application, that delivers responses as a stream. Not everything in one block, but we will have a counter, and step by step, the responses will be sent back, to the client application. This is a kind of streaming, bidirectional type of communication. And for this, APGX cannot directly be used, but it can be used as a service extension to perform at least some security validation, like the verification of an API key, the verification of an access token, etc., in order to identify the client application. If we don't go with Apigee, we will not be able, to identify the client application. We will not be able to mediate a token that is presented to the cloud load balancer, but that needs to be different, and that needs to be different, when we send this token to the backend application. So token mediation, that's also a very good use case for this type of pattern. And this is exactly what I will show you during the demonstration. And again, you can also operate at the response level. If, for instance, you need to send some specific type of headers in the response back to the client application, again, this is something that can be executed by the API proxy on the response side. So I will show you quickly during the demonstration how the load balancer is configured regarding the service extension, how we can plug it to your APGX platform on a specific API proxy. And then I will, of course, perform some demonstration and activate the debug trace in order for you, to see exactly how this API proxy executes. And the new type of use cases, this that can be leveraged. And again, gRPC streaming is a perfect example where APGX cannot be directly used, but as a sidecar proxy, APGX of a load balancer, APGX is now you can use it now based on this service extension capability. So what are we solving? Just to come back on what I said, currently APGX only handles unary gRPC, but many customers, it's maybe your case, need bidirectional gRPC streaming, and that's not possible with, I would say, a normal type of pattern, but with service extension, as I just described, you will have the possibility to leverage the GCP load balancer support of bidirectional communication with gRPC streaming, and use APGX as a sidecar to the load balancer in order to, as I said, perform some security controls like API key verification, access token verification, spike arrest, quota enforcement, all these different things. You can benefit from it using APGX as a sidecar proxy to the load balancer. So just some flow details before going to the demonstration. First flow, very simple, gRPC without service extension and without Apigee. Okay, here we have just a client application here, a backend, so Cloud Run, for instance, with based on gRPC, that acts as a gRPC server. So very simple, client and server. We have, of course, here the gray rectangle is Google Cloud external load balancer, and we have here all the details of what is included into Google Cloud external load balancer. Global forwarding rules, the target proxy, URL map, backend service, and serverless network endpoint group when you connect with a Cloud Run application. So you probably know all these different layers that are components that are part of a cloud external load balancer. You probably already implemented and configured, this type of load balancer. And basically, this is exactly the flow, if you want to connect with a gRPC-based backend application. The client first sends the request, of course, to the load balancer. This is the facade, in front of the gRPC service. And from there, we go. So in blue, we see the request flow. So going into the different components of the cloud load balancer in order, to reach here the gRPC backend service, the Cloud Run backend service in this case. And the response flow in red, the response goes back, through the different components, the different layers before being sent back to the client application. So it works very well, and you can implement, of course, a bidirectional gRPC using this technology. The point is that what if you want to add Apigee to the flow for security? We could add Apigee. We would like to add Apigee mainly for security reasons. As I said, token mediation. Here you need to provide an ID token to this gRPC Cloud Run application. So the ID token needs to be created here by the client somehow before creating the request, and it will be injected into the request in order to reach here the gRPC backend application. But what if you want to identify the client application? What about the monetization, the possible monetization of this gRPC backend application that you have developed? You put a lot of time into the development of this Cloud Run gRPC application, and now you would like to monetize it. And what about monetization? So all these different things, we support them on Apigee. Validating an access token, monetizing traffic, we can do that. Spike arrest, the same. If we want to limit to perform some rate limiting, quota enforcement, if we want to negotiate with different partners the consumption of this gRPC application, all these things, we can do it with Apigee, but without Apigee, as we can see it in this diagram, we are not able to do it. So now we are going to use service extension. We have this possibility, as I described it, at the cloud load balancer level, at the global forwarding rule, we are able, to execute an extension, and not only on the request, also on the response side, which is something important. So in blue, again, the request, and in red, the response. So here we have exactly the same components as described on the previous slide, but at the forwarding rule level, we are able to call an extension. That's a gRPC call here to connect, to communicate with this extension. And from here, we can reach an Apigee runtime that will perform an API key verification, an access token verification, a quota enforcement, a spike arrest execution, etc., etc. In order to monetize the same, we would have some monetization limit check, etc. So different policies that are part of the monetization capabilities of Apigee. So that can be delivered here by the Apigee runtime. And of course, once the request flow has been processed, we can deliver here a response in terms of response that can be used by the forwarding rule, and that in order to inject, the different headers, for instance, that can be injected, to the gRPC application. So as an example, I come here with an API key. The global forwarding rule calls the extension. On Apigee, I can verify the API key. I can now mediate the API key with a token, an ID token that needs to be transmitted in order to connect with the cloud application. This token will be here sent to the global forwarding rule, and the token will be propagated to the gRPC application. Okay, that's an example. Again, on the response side, it's also somehow important to be able to operate. So on the response, the flow will go here to the forwarding rule through the different components, and at the forwarding rule level, I am able to call this Apigee, the Apigee runtime through the extension, the same as before, but on the response processing side, I am able to perform what needs to be done and deliver here the response back to the forwarding rule that is sent back to the client application. So if I need to inject some specific headers or whatever, or I need to filter some header also, to perform some header mutation, it's also possible to do this, of course, at the response level. So this is a view of the request, response, and how we can use here the service extension with Apigee as the proxy. Again, no targetless API proxy that we will execute here on the Apigee side. There are some limitations. I will show you this. When you create an API proxy that is used as a service extension from a load balancer, an application load balancer, the extension processor is applied at the load balancer level. This is what we have seen. And all the traffic passing through the load balancer is processed by the same API proxy. And there is, for this, no base pass consideration, because the same API proxy is used, for the extension. So no matter what the call is, you cannot use the base pass information in order to execute some specific type of processing. It's the same API proxy that will be executed in this case. So no base pass or URL distinction in this case. There are some quota also, regarding inherited, from the cloud load balancing. There are two relevant limits I want to share with you, and quota, that I want to share with you. So the maximum number of traffic extensions per load balancer is 5. That's important, and the maximum traffic extensions per projects is 100. Yeah. So these are the two limits that are important to consider when using service extension with APGX. No gRPC payload. You cannot modify, manipulate, modify, or inject some information into the body, the payload of your gRPC traffic. Yeah, so that's important, and that's not the idea. The idea is to modify, inject, mediate some token as I described, but it's not to modify the binary payload of the gRPC communication. That's not the purpose of Apigee. The idea is to act as a security endpoint. What we could call it a PDP, policy decision point, in order to take the decision. Yes, you can go to the backend gRPC service, or no, because for different reasons, a quota is not respected. There is a spike arrest that has been that has been also triggered, etc. So for an API key is not valid, so for different reasons, you will be able to reject, but we don't touch the gRPC payload. That's important. And for service extensions with Apigee X, there are a set of policies that are not supported there. Publish message, external callout, integration callout, service callout, set integration request, message logging, and generate GWT. So these policies are not supported at the API proxy, on the API proxy that you will use as the proxy for your service extension, what we call the Apigee extension processor. So these are the limits. A part of these limits, of course, you can use the different policies that you want to use for this. There is a possibility, to use these policies if you really need to use them. But again, I encourage you not to use these policies because the idea is not to waste, I would say, time, in double quote, waste time into the API proxy. The idea is to keep the performance of the system, and of the communication between the client and the backend service that needs to be reached. But if for some reasons, you need to execute one of these policies, it's possible. From the proxy, you can call a shared flow, you can make a flow callout, you can execute a flow callout, and on the shared flow, that will be reached by the API proxy acting as an Apigee extension processor, you can execute one of these policies. I did some tests with service callout. It was possible to execute the service callout. I have not been able to test the other policies, but at least for the service callout, it was possible. Yes, there is a question. Yeah.
Yes, sorry, Joel. When you talk about calling a share flow, do we have some policies that are not supported on the share flow when we do an external callout?
No. On the share flow itself, there is no limitation. Yeah. So that's why this limitation only applies at the API proxy level that is reached by the extension. But if you need to implement one of these policies, so you cannot do it directly at the API proxy level, but you can do it on a shared flow that is called by this API proxy. So you can make a flow callout, and on the shared flow, that is the target of this flow callout, you can, if you want, implement one of these policies. Yeah. So it's a way to it's a kind of workaround if you really need to execute at one moment, this type of policies. Okay, so now we can go to the demonstration. So first, I will use. So I have on my. I'm of course going to work on a GCP project, a Google Cloud Platform project. I have there. I will show you, a Cloud Run application, a very basic Cloud Run application. The service is hello world.greeter, and there are two methods, say hello and count. The count one will be able to deliver the streaming mode, and then I have my client application. And in this first part of the demonstration, as you will see, the client application will first create an ID token because the Cloud Run application requires an ID token in order to execute its logic. And when the ID token will have been created, I can use it now with gRPC URL. So it's a very common tool in order to perform a gRPC to generate some gRPC traffic. Yeah, so gRPC URL. I will give you, some resources at the end of this presentation, but that's very useful in order to connect with the gRPC server. So it acts as a gRPC client with a different mode. Streaming mode is supported, which is interesting. And here we will directly use, the Cloud Run hostname in order to connect with this Cloud Run application. So that's very basic. We can do it like this if we want. That's possible. But okay, in that case, as we said before, what about identifying the client application? What about quota enforcement, rate limiting, possible monetization, token mediation? All this, of course, is not supported in this case. So we will add a cloud load balancer in front of this Cloud Run application, but the principle is the same. I need first, as a client application, to create an ID token, and here I'm using exactly the same command, except that I go through the load balancer that will be connected here to the Cloud Run application through a serverless network endpoint group. Okay, so not very different. But now that I have a cloud load balancer, and this will be the last part of the demo, I can now use service extension in order, to connect with an API proxy that will be deployed on an Apigee X organization, specifically on an environment. And with this API proxy in place, I can now perform API key verification. So I can identify here my client application. The client application will not deliver an ID token, just an API key that will be created here at the Apigee level. So we have a concept of API key, API product. We will have to create a product. I will show you this. Once we have the API key, the client application can use this API key to connect to the backend through the load balancer, and through the service extension, we can perform the API key verification. If not valid, we reject. If it's valid, okay, no problem. Then we can perform the token mediation, create an ID token that is required by the Cloud Run application using a service account. We will do this, but that's completely managed by Apigee in that case. And the load balancer, doesn't have to take care about this. Yeah. And then we have the token mediation. And on the response, we go back to the API proxy, and we will set a specific custom header, x-custom, with a static value. It could be, of course, a value set dynamically, but here it is just to show you through this example that we can also operate at the response level here. So on the response, on the request, sorry, API key verification and token mediation, and on the response, we inject a static value to be sent back to the client application. So let's go, and I will share my screen now. Yes, you should see my, yes, perfect. So you can see now my beautiful GCP platform. Yeah. So what I'm going to do here is first show you, yes, why not? The Cloud Run application. So let's go to Cloud Run. This is my Cloud Run application, Apigee sample xproc gRPC backend. Okay, we can have a look quickly on it. So this is the target. I will use it just after, and we can go here to the source just to see, how it is implemented. So it's a very basic gRPC server that is implemented. Okay, nothing special on that. And we have here, as you can see, two methods that are implemented. The first one is say hello. Okay, just to say hello, it returns hello from server. And the second one is count2. In order to execute as a counter, we provide an integer, and we are using a counter, on this integer. So if it's 10, for instance, every 1 second, we will deliver the result of the counter as a stream back, as a response, as a stream in the response to the client application. Okay, so two very basic implementation for this method, but this was just, to show you this what we are doing here. Okay, we also have. So yes, I can show you this directly. So now I'm just going to set. So first, I will go directly, to this Cloud Run application without load balancer. So I'm just going to export here, the host name with this specific variable CR host name, which is, the host name of my Cloud Run application. And now I have to. So let's go first without creating an ID token. Yeah. But if I'm doing here say hello, so I am using here gRPC URL, the tool that I mentioned before. I provide here an ID token. It shouldn't be valid. Yeah, if it is, I will modify it. But if I try to access, you see here I have no ID token, or not a right value that has been transmitted. And as you can see here, I get 401 unauthorized because the ID token is not correct, is not valid. So I'm going to first generate an ID token. So let's do this first. So here I export an ID token, and I'm using gcloud of print identity token to generate an ID token. Once I have this ID token, I can execute my gRPC URL command. In this case, I will inject, of course, the token as a bearer token, the same CR's name, and I am here reaching the service hello-world.greeter with say hello method. And as you can see here, I will get a message, hello from server. This is a static message that we have seen previously. I can also use the count2 method, yeah? And the same here. So Now we have something based on streaming. So every second I deliver a response. The counter was set to 5. So every second, 1, 2, 3, 4, 5, I can see here the response sent back by the gRPC server as a stream in the response. Okay, but at this point, as we said, we have nothing to see with APGX. There is no load balancer, nothing. So now we are going to add a load balancer. So this is what I already did, but I'm going to show you, the load balancer itself. So this is a load balancer here that I have that has been created. Okay, so that's an external load balancer, L7 load balancer, HTTPS. Here you can see the certificate part of the load balancer. There is a backend service that has been set, and this backend service, of course, consists in pointing to my Cloud Run application. My Cloud Run application is here, and we go to the Cloud Run application through a network endpoint group, serverless network endpoint group, which is a common way, to work with a Cloud Run application from a load balancer. So I have this load balancer in place, no problem. And now everything is okay. I am on the second part of the demo where the load balancer sits in front of the Cloud Run application. What I did here directly is adding the service extension to this load balancer. This is what I'm going to show you now. So here we go to service extensions, which is part, as you can see, of network services. Yeah. Let's go to service extensions. I can see here different service extensions, and these service extensions here has been set and is used by a forwarding rule, Apigee sample xproc LB, that I have just that I showed you before, forwarding rule here. So clicking here and detailing here this service extension, I can see here. Of course, you can create this service extension with gcloud command. I will come back on this just after. And you can see here all the details, okay? So I have different information here. My extension, I will reach, of course, Apigee through a backend service. I need a connectivity, of course, from the extension to the Apigee X platform. So I need a backend service for this. This is the backend service that is used, okay? I can define here different information. And there is one metadata information here, Apigee-extension-processor, which specifies the name of the API proxy that I will use on the Apigee side to execute the logic on the request response side and the logic that is needed here. Here I use the backend service, and this backend service, as you will see, will point to a private service connect network endpoint group. Okay, and here this private service connect network endpoint group directly here points to the service attachment of my Apigee X platform. Okay, so this is a link, the direct link through PSC, Private Service Connect, with my Apigee X platform, and I have set, the Apigee, the API proxy that needs to be that is targeted, on this Apigee X platform. So I have all the information I need. I know which Apigee X platform to reach, and I do it with the PSC, Private Service Connect. And on this platform, I know the API proxy that needs to be executed. This is the proxy that we have seen, and that is set through the metadata key Apigee-extension-processor. Okay, so this is on the GCP side, GCP network services side. Yeah, the load balancer, the service extension. So the load balancer is plugged with my Cloud Run application, and there is a service extension to reach the API proxy, xproc proxy on my Apigee organization. Okay, so now if I switch, I'm going to go here on my Apigee just to show you, of course, this API proxy. So once the extension is in place, you can go here, to your API proxy. You have to create this API proxy. Of course, I just did it before, before this presentation and demonstration. So this is my proxy, if you remember, xproc-proxy. So this is created in a specific environment. It's not an environment that is used by my other proxies. When you work with service extension, you have to create one dedicated environment and one environment group associated with this environment that will contain all the API proxy that needs to be executed from a service extension. So what we call Apigee extension processor. So all this Apigee extension processor will be deployed into a dedicated environment. You can choose the name, of course, but they are not deployed on the same environment than your other proxies. And remember that we will not use the base path, so you can choose, the base path you want when you configure, this API proxy. The base path information will not be important in this case. Yeah. The name of the proxy is important, and the fact that it's deployed into a specific environment is also important. Apart of that, you can create the configuration of your proxy as needed. So in my case, I will have an API key verification. So we can see it here. I will get the header API key and perform an API key verification based on the value of this header. As you can see, there is no target. It's a no target API proxy, targetless API proxy. Second, I will perform the token mediation. Very simple here. I'm just here getting, generating, a Google ID token based on a service account that will be set at the API proxy level. So when I deploy the API proxy, xproc proxy, I can set a service account, and this service account is used in order, to generate an ID token that is needed, that is required by the Cloud Run application. So my client app will not have to transmit this information. It will need an API key will be required, but the ID token itself, as you can see it here, will be generated by the API proxy itself. Yeah. So this will be performed on the request, as we can see here, request, and on the response. I want to set, as I said, a custom header, so x-custom, for instance. So this is the name of the header with the value. Of course, this value could be generated dynamically. We could also perform the reverse, I would say, filtering headers, removing headers from the response. But as you can see here, the idea is to show you that you can operate at the response header level. So that's important here. So now this proxy is in place. It has been deployed. Nothing else particular on this for this API proxy. And now so of course, once the proxy is in place, we are going now to work with an API key. There is a requirement for the client application to present a valid API key. So if I work with an API key, automatically I need to set an API product. So of course, this is something that needs to be done. So here I have got the xproc product, okay, and this xproc product defines different gRPC operations, okay. So of course, let me edit it, but you can see here the two operations, the two methods on the service hello world.greeter. I have two methods, count2 and say hello. These are the two methods. I could add here a quota if needed, yeah. And I also included here reflection, the server reflection info method, and that's also something important. You need this server reflection info, because in gRPC, the server reflection info service is used to enable what we call server reflection. It's a feature, that allows clients to dynamically discover the services and the methods available on a gRPC server without needing, pre-shared protofiles. Otherwise, you need to work with protofiles, so protocol descriptor files. We don't want that. We prefer, in general, to have a dynamic discovery of the services. And for this, we work with this server reflection info method and service and method. That's why you need to declare them here into the list of gRPC operations, because your clients at one point will, generate this type of traffic in order to, dynamically discover the two methods, the service and the two methods, associated with the service, and how to contact, these two methods in terms of request and what is the type of response that will be received. Everything is described through this server reflection capacity. Okay, so that's why you need to declare them. So here we set that directly at the gRPC operation of an API product. Okay, we could set here a quota, of course, in order to perform some quota enforcement. And what we have done here also is create an application. So we have here xproc gRPC app, And this application here, of course, once created and once the relation has been created with the export product, we can benefit from a client credential. And so I'm going to use this API key, this credential, in order to provide the API key. Again, I could do a key and secret verification. I could ask for an access token that would be previously generated and verified by the API proxy, XProc proxy. Of course, all the use cases are possible, but at least here, I follow the best practice, which is to identify the client application through a client ID and what we call here an API key. Okay, so this is all the different elements that are that have been set at the Apigee level: the API proxy, the product, and the client application. So now I'm coming back to my XProc proxy, okay, and just to enable the debug trace, and so we can see exactly what's happening here at the Apigee level. Yeah. So I'm going to come back here to my Cloud Shell here. And this time, as you will see, I will set an API. So I'm going to set now the load balancer hostname. So I don't want to work directly with the Cloud Run application. I want to go through the load balancer. So this is the hostname of the load balancer. So you can see the IP address and nib.io to work with the host instead of an IP address directly. I don't need to set any ID token at this point. Okay. But what I need, is to, of course, set an API key. So let's set, the API key. So I just made a copy paste of the API key that was previously set. Okay. And once I have set the API key, now I can call the gRPC service through the load balancer. I will call the extensions. This is something we will see here. We will see the execution of the proxy. So here you can see the load balancer hostname, port 443. This is the service. That's another request, that has been transmitted. It's not me. And this is the API key, that we want to transmit. Okay, so I'm just pushing this request. I can see here the message "hello from server," and I should see here in a few seconds different requests. So I see two requests. The first two are the server reflection info request that I just mentioned previously. Yeah? So if I'm coming here, you can see the request content. You see here server reflect info. So the first two are this type of request, and the last one should be, and we will see it here in a few moments, should be here the say hello method from the hello world.greeter service, that has been requested. Okay, and as you can see here, the API key verification has succeeded, no problem, and I can see the response here back on my gRPC URL. So I'm going to add here on my gRPC URL a command. I'm going to add here the verbose mode here, gRPC URL, very verbose, in order to get all the details. So I can see first the message. The API key verification has been done. I can reach the service. So the ID token has been transmitted. Yeah. So I don't see the ID token here directly because that's something that is, of course, hidden. I can see, of course, that there is an authorization header that has been created, but I will not be able to see. So I can see, yes, I see it here directly because it's X serverless authorization. It's not authorization, it's X serverless authorization. And I can see here I could, of course, obfuscate, this information. No worries, but here I can see, the bearer token, the ID token that has been generated by my Apigee assign message policy. Okay, and that is transmitted to the Cloud Run application. And on the response, here I can see that the X custom header has been set because I can see it. If you follow here, the response, you see X-custom ABCD1234 that has been set, on the response here. The same, of course, if I don't provide the developer API key. So let's say, for instance, I'm going to change the name here of the value. So the API key is not valid here. I can see here that I receive a false string, invalid API key, because yes, the API key is not valid, so it's rejected. It has been rejected by the API proxy that performs, this control, this verification. Okay. Last but not least, I will just use also the last one, the streaming, the real streaming mode, which is based on a counter here. So I will probably here modify maybe the value of the counter here to put some more info. So first I connect, I have all the verification, the response is sent back, and then the connection has been established, and the responses are sent back as a stream to the client application. Here I set 15, so I can see here my 15 responses sent as a stream to my client application. Again, I could have here enabled the verbose mode, yeah, which is also interesting in order to list the different elements. So I can see here, all the resolution that has been done, with the server reflection info. Yeah, so I can get here all the information from important, for the client application. I can see the response headers. So here I can check that the X custom has been transmitted, and on Apigee, of course, everything is okay regarding, the API key verification, the token mediation, everything is in place, and the different responses have been transmitted. As I can follow it on this trace directly on my Cloud Shell environment. Okay. So this is what I wanted to show you today. Yeah? So gRPC streaming. So I'm just coming back quickly, to the application before the conclusion. So that's what I wanted to show. There are some resources. Of course, you probably want, to test it. The best way to test it is to go through the Apigee samples. All what that has been presented today, you can implement it directly through an implementation, a configuration that is proposed in the Apigee samples GitHub repository, which is managed by Google Apigee, by the Google team. And you can install exactly what I have demoed today. The Cloud Run service, etc. If you have a GCP environment, you can exactly follow the different steps, install the gRPC URL command, and install, the different elements that you need. A load balancer. So first, a load balancer and a direct connection without Apigee, and then step by step, you will add the service extension. And have exactly, this flow on the request, on the response, as I showed you, and you can manipulate, the different policies that you want to execute at the Apigee level in order to test, this sample as you want to test it. Yeah. And last but not least, there is a cleanup process to clean everything, the extension, the developer app, everything that has been installed on Apigee, so you can quickly test and clean your Apigee environment. And I encourage you really, to use, this Apigee sample, but because you can find a lot of different implementation, very basic implementation, or some things more elaborated as we showed today. But that's a real, interesting GitHub repo. Yeah. That's okay for me. If you have any question, of course, please feel free to ask for your question. I shared, also, this Apigee samples link into the documentation that will be shared with you in the coming hours or days, probably today or tomorrow. So yeah, do not hesitate. If you have any questions, we have a few minutes for Q&A.
Yes. Thank you so much, Joel. That was a great presentation. We don't have questions in the chat, but everyone, please feel free to raise your hand or open your mic. Also, if there are any forum questions we have left unanswered to you, and if you'd like to bring those into the conversation, you're more than welcome to do so.
Exactly.
Alrighty. Then I guess it was a pretty clear presentation, Joel. Thank you so much.
Thank you,
I'm going
Alexandra.
to take it back to wrap up this session for today. It's been great having you back to this presentation, Joel. It's always good to see our experts coming back to this forum.
Thank you, Alexandra.
So, well, everyone, I just opened the poll for you to rate your satisfaction with this event. So please make sure you leave the feedback with us. Or if you'd like to go more in depth to some topics or kind of sessions you would love to see in this scenario, please feel free to scan the QR code and we'll take a look at your feedback. That's very valuable to us. With that, we have some upcoming events. I would love to share the invitation with you. For those in the EMEA region, we'll see you next Wednesday at 10 a.m. with Luis and Itzazo, so that they're going to present to you the updates with advanced API security, all things about AI security and API. So that's a really interesting session. Yesterday, we had a regional session over here in North America, and it was a well-received session. So we look forward to see you there. You can find the invite through the Google Cloud community. And for those in Germany, we'll have the summit for Apigee and application integration on July 1st, which is going to be like in 2 weeks from now almost. So we'll look forward to see you there. Right now, as we speak, our community in Madrid is having their summit. So it's a great spot for you to connect with the rest of us, Google experts and the community enthusiasts around these topics. And with that, I'm going to make a pause in case there's a question you would like to share before we close.
One question, this summit in Germany will be in English or in German language?
I'm not so sure about that. I will check that and I'll get back to you, Roman.
Yeah, thank you. And Joel, thank you for this presentation. It was really informative and interesting.
Thank you, Roman. Thanks a lot.
Yeah, thanks, Roman, for joining. And by the way, all of these sessions are free. I forgot to mention that, so no cost for you to join us. All righty, team. Well, Joel, thank you so much for giving us this great presentation. I'll make sure
You're
to
welcome,
share the
Alexandra.
recording and the deck. Everyone,
Perfect.
have a nice day. We'll see you soon.
Bye-bye. Have a good day. Bye-bye.